In 2012, an estimated 13,712 people in the United States lost their lives to HIV, which begs the question, how close are we to solving this worldwide pandemic? A new treatment for this HIV has recently surfaced and offers a new way to attack this problem. But before we discuss this new treatment, it is important to remember what we're dealing with. Scientists determined the source of HIV to come from the West African chimpanzee. They believe that the simian immunodeficiency virus, SIV, was likely transmitted to humans through the consumption of chimpanzee flesh. The virus spread across Africa and then began to affect the rest of the world. The first identified case of human HIV-1 was found in a blood sample taken in 1959 from a man in Kinshasa, Democratic Republic of the Congo. Further genetic analysis showed that HIV-1 may have come from a single virus in the late 1940s or early 1950s.
HIV, which stands for Human Immune Deficiency Virus, is similar to other viruses such as the common cold or the flu, but there is an important difference. Over time, your immune system can in fact clear out most viruses from your body. This is not the case for HIV. Once you have it for life. Once inside the body, the HIV virus starts to primarily infect T cells, which are cells with CD4 cell surface receptor molecules. These CD4 cells are critically important to your body's immune system, as they are white blood cells used to fight infection. After HIV infects a cell, the virus goes on to change its genetic material through the process of reverse transcription, which creates a double-stranded piece of DNA. After this process, it then inserts its DNA into the nucleus of the infected cell, with the help of the enzyme integrase. It inserts its DNA into the infected cell's DNA, where it can remain hidden and protected from your immune system. It spreads throughout your body by replicating itself inside your cells, and then buds out of the cell and repeats the process. In the long term, the HIV virus will eventually deplete your CD4 cells to the point that your immune system can no longer protect your body from other illnesses. Within the beginning stages of being infected, people with HIV develop flu-like symptoms. This acute HIV infection, as it is called, may last for a few weeks. Some symptoms of this include headaches, muscle aches, chills, and fever. During the primary stage of the HIV infection, the symptoms may be mild enough to go unnoticed, but it's in fact during this time when the HIV virus spreads most efficiently. As time progresses and the virus begins to multiply, you will develop more symptoms such as weight loss, swollen lymph nodes, shortness of breath, and fatigue as examples. If a person chooses to not receive treatment for the HIV virus, the disease will then progress to be AIDS.
Researchers believe that they now have developed a vaccine to treat HIV. Scientists have genetically engineered a new protein that has the ability to inactivate all strains of the virus. The protein works by mimicking the two receptors on the immune cells that HIV normally targets and infects. When the virus binds to this protein, it unsuccessfully attempts to infect the cell. The virus is then incapable of making any future attempts to infect the cell. The protein was shown to neutralize 100% of neutralization-resistant strains of HIV-1, HIV-2, and SHIV-AD8, a genetically engineered cross between SIV and HIV. This protein has been tested in cell cultures, mice with humanized immune systems, and macaque monkeys infected with SHIV. This treatment provides a much higher degree of protection than the strongest anti-HIV antibodies present in the body's immune system. It claims to be effective, long-term, and near universal. Scientists argue that larger experiments in non-human primates are warranted, but use of this technique in humans may be a far-off prospect.